We've talked about what to do with exponents when we're multiplying exponents that have the same base. But what do we do when the exponents have different bases? Well, all we can do is simplify as best we can using what we already know about exponents to the 0 power and to the negative powers, and what we just learned about multiplying exponents with the same base. We're going to use those same tools as well as another property, which is the associative property of multiplication. And hopefully you remember that. When we have a times b, that is the same as b times a. We can rearrange our different terms for multiplication. That's what we're exactly going to do in the first problem. So here we have problem A. And in problem A, we are multiplying all of these terms together. So this is 5 times x to the fourth. It's not just 5x to the fourth. It's 5 times x to the fourth times x to the ninth times 3 times x. So all of these are being multiplied together. The commutative property of multiplication says that we can rearrange these. I may have said associative property earlier. I meant to say commutative. But again, the commutative property says we can arrange these however we like. Now, I know that I can multiply 5 and 3 together. They're both constants, so that's what I'm going to do. I'm going to group 5 and 3 together. This is the associative property, by the way, when we're grouping them with the individual parentheses. Now, what else can I group together? Well, I've got a bunch of x's. They all have the same base. So let's group those together. X to the fourth times x to the ninth times x to the first. And let's do our multiplication. So we have 5 times 3 is 15 times x to the all of these things. And since they're all positive, we're just going to add them together. 4 plus 9 is 13, plus 1 is 14. So we get x to the 14th. And to simplify that, we'll write that as 15 times x to the 14th. And we're done. So let's try another, and we'll do this one right here. We've got negative 4c to the third times 7d to the second times 2c to the negative second. So let's go ahead and multiply what we can, right? So we can group the negative 4, the 7, and the 2 together. So we wind up with negative 4 times 7 times positive 2. And let's group the variables in the way that we can. We know that we've got c to the third, and d won't group with anything that's c to some power, but this other c will. So we wind up with times c to the third times c to the negative second, and then we'll just add our d out on the end, d to the second. There he is. Now let's go ahead and deal with what we've got. Negative 4 times 7 is negative 28 times 2, which is negative 56. And that's going to be multiplied by c to the third times c to the negative second, which we add these together. 3 plus negative 2 is 1, so c to the first power. And that leaves us with our d to the second power there. Don't know where that negative came from. D to the second. And we'll put that right there. So d to the second. And we can't really do anything with that, so that just becomes d to the second. So this is our final answer, negative 56 c d to the second. And let's do one last example. We'll take this one here. J to the second times k to the negative second times 12j. So we can see that we only have one constant here in the front, and that's just our 12. So all the rest of these are technically being multiplied by 1, but we're not going to write that in. So we're going to leave with 12. We lead with that. Now, we can combine our j's. So we'll combine j to the second right there with j to the first. So j to the second times j times k to the negative second. So we're going to have to deal with that negative exponent in just a second. In the meantime, we'll take care of our 12. And our two j's are multiplied together. That gives us j to the third. And then since we have times k to the negative second, we can't leave it like that. We've got to get rid of that negative exponent. So we'll move it down to the bottom. We'll take its reciprocal and make it with a positive exponent. So that's going to be 1 over k to the second. So we'll just put k to the second down here on the bottom, and that is our final answer. And that's really all there is. So I'm going to let you take off on the homework for today. That'll be posted in your Google Classroom.